Yes, this is Professor Bennett-Bell, and we are going over set concepts. Okay, so sets are generally named with capital letters. For example, we're going to use the capital letter N that represents natural numbers. So when you think of natural numbers, think of when you're in first grade, maybe even before then, maybe when you're 1 or 2, when you start counting, you think about the counting numbers. So when you start counting, you start at 1. Yes. So we're going to start 1. What comes after 1? 2. Then 3, 4, and so on. Okay. So those are the counting numbers. And yes, the counting numbers are represented as a set. So let's try a quick example. Let's write the set that is explained here. So it says X such that X is N. That's a capital N. We know what capital N represents. We just went over this. Natural numbers. So think about the counting numbers. And this reads 3 less than or equal to X, strictly less than 9. And we're going to put this in roster form. So let's start off with the first part here. It says 3 less than or equal to. When you have that less than or equal to, the equal to underneath of the less than sign, you include that number. So we're including 3. And we're going to keep going. 4, 5, 6, 7, 8. Question. Do we include 9? Is this strictly less than 9 or less than or equal to 9? Yes, this is strictly less than. Therefore, we do not include the 9. So you see here, we include the 3 because we had the or equal to, but we do not have or equal to for the 9. So we do not include the 9. So where it says 3 is less than or equal to X and strictly less than 9, that set would be represented as A equals 3, 4, 5, 6, 7, 8. And with this notation, the roster notation form, you want to make sure you use the squiggly brackets and you do not use the words and, but you use commas to separate. Okay, let's try another roster form. So here we have a table below that shows cities in different states. We have West Palm Beach, which is obviously in Florida, where we are located. Well, where I am located, but other places where you live might not have West Palm Beach. Chicago is in Illinois. Savannah is in Georgia. Atlanta is in Georgia. Miami is in Florida. A lot of people know where Miami is. Jacksonville is also in Florida. So let's try this roster form one more time. So it says, let C be the set of cities in Florida. I want you all to pause this video and try to see if you all can write this down correctly and then check your answer. So we're going to have West Palm Beach is the first one. And we're going to separate with a comma. Are there any other cities that's represented on this table that are located in Florida? Miami and Jacksonville. It does not matter what order you put these in, as long as you have the correct elements in this. Now, one more thing I want to show you here is that it says, let C be the set. So we are missing one thing, C. So we'll have capital C equals West Palm Beach, Miami, Jacksonville. Okay, let C represent the cities in Illinois. C equals, how many cities are represented here that are located in Illinois? We only have one, Chicago. Okay, and the last example here, let C be the set of cities in Georgia. So go ahead and pause this video and see if you'll be able to go ahead and represent this set. Okay, so C, we have Savannah and we have Atlanta. So as you can see, we have different sets and elements all over the world. You can represent this mathematically. These are very simple examples, but a relevant cause, because it's very easy to confuse these. I want to make sure that everybody fully understands that you can have elements in the cities and you can make sure that these are equivalent, because we have West Palm Beach, Miami, and Jacksonville. This is the same as Jacksonville, Miami, West Palm Beach, or Miami, West Palm Beach, Jacksonville. These are the same elements. It does not matter what order they're in, as long as you have all the correct elements in the set. Okay. Now let's go to a couple of definitions. Okay, set A is equal to set B. This is symbolized by A equals B. If and only if set A and set B contain exactly the same elements. They do not say that you have to have them in the exact order, but they have to have the exact same elements. Let's do an example. So if I have set A is, let's say 3, 4, 5, and set B is 5, 3, 4. When you look at the elements in the set, you have 3, 4, 5 for set A. And in B, you have 5, 3, 4. These are same exact elements. That means these two sets are equal. Therefore, we can conclude A equals B, because these are the same exact elements. That's what equal means. Let's try one more example. Let's have A equal, let's say apple, red, pie. B equals pie, red, apple. Are these equal? Yes, these are exact same elements. They're just in different orders. Okay, apple is in A, apple's in B. Red is in A, red is in B. Pie is in A, pie is in B. Exact same. Therefore, A equals B. Okay, then we have the cardinal numbers of set A. That's symbolized as N of A is the number of elements in A. quick example of this, if we have A equals 5, 6, how many elements are in A? There are 2 elements. In set A. Okay, let's do one more example. Let's have a set C. We'll have a car, train, bike, skate. How many elements are in C? It's a cardinal number. We have 1 element for car, 2 element train. Let's keep counting. 3 bike, 4 skate. Therefore, we have 4 elements. In C. Okay, and the last thing we have here, it says set A is equivalent to set B if and only if n of A equals n of B. This is referred to the cardinal number, the numerical elements in each set. Note, any sets that are equal must also be equivalent, but not all sets that are equivalent are equal. Let's do this quickly. So let's have a set A. Let's have a set B. So let's say we have yellow, red, pink. And then we have dog, cat, pig. The question here is, are these equivalent? We have to make sure we understand what equivalent means. Do we have the same numerical value of elements in each of these sets? We have 3 elements in A and 3 elements in B. Therefore, these are equivalent because they have the same number of elements. These are not equal. They're not the same exact elements in each of these. However, they are equivalent. They're the same cardinal number in each. There are 3 here, 3 elements here, and there's 3 elements here. Therefore, A and B are equivalent. Let's try one more example for equivalent, and then I'm going to test you all. So we have A, then we have B, so let's have January, February, March, let's have December, Then let's have 3, 8, 7, 5. Are these two sets equivalent? Yes. There are 4 elements in A and 4 elements in B. Therefore, this is equivalent. A and B are equivalent. Okay, now time to test what we've learned. Example 1. Example 2. Example 3. Okay, example 1, it says set A equals short, medium, tall. B equals medium, tall, short. How can we describe these two sets? Yes, they are equal. And like I just said, if something's equal, it's also equivalent, but it's not vice versa. So this would be equal. And as we know already, if it's equal, it's also equivalent. Example 2. A equals three, 6. B equals 8, 6, 9. And how do we represent this? Equal, equivalent. This is neither. This is neither. They have 2 elements in A and 3 elements in B, and they're not the exact same elements, so they're neither equivalent nor equal. Then let's go ahead and do example 3. We have hot, cold, and then we have yellow, orange. Equal, equivalent, or neither. These are equivalent because there are two elements in A and two elements in B. Therefore, these are equivalent. Okay, hopefully this helped. I will talk to you all later.